Material and temperature rise. Today we aim to investigate how the material affects its temperature rise for a fixed mass and fixed amount of heat energy supplied. To do this, we have 4 blocks of different metals, all each of 1 kilogram mass, into which we can insert a thermometer to measure its temperature and an electric heater. We use the thermometer to track the temperature rise caused by the electric heater. We also have a joule meter, and this is to monitor the amount of energy in joules supplied to the heater. This is so we can measure the temperature rise for each material when subjected to a fixed amount of heat energy. So for each metal, we will supply 5 kilojoules of heat energy and record the temperature rise. First up, we have aluminium. Having measured the starting temperature of aluminium as 22.2 degrees, we can start the joule meter and supply 5,000 kilojoules to it. So we can turn our heater off because we're at 5 kilojoules, and we can read the temperature as 27.6 degrees. So for aluminium, the rise in temperature was 5.4 degrees. So next we're going to measure copper, which has a starting temperature of 22.4 degrees. So we'll start our joule meter. So we're coming up to 5 kilojoules, and our temperature is 35.4 degrees. So there's a rise of 13 degrees. Next we have brass, whose starting temperature is 22 degrees. So again, we're coming up to 5 kilojoules. And we have an end temperature of 35.3 degrees, 35.4 degrees. So that's a temperature rise of 13.4 degrees. And finally, we have iron, which starts off at a temperature of 22.2 degrees. So we'll turn the heater on. And we're approaching 5 kilojoules again. And reading our final temperature for iron, it is 33.2. So we have a temperature increase of 11 degrees. So here's our table of results, and we can see that brass increased temperature the most, while aluminium increased the least for being subjected to 5,000 kilojoules of heat energy.